The sun is going dark tomorrow. Not metaphorically, not symbolically, literally. On August 12th, 2026, the moon will pass directly in front of the sun, and for a narrow band of the planet, day will turn to night in the middle of the afternoon. That's the total solar eclipse, but that's not the story I want to tell you today. The story is what's converging around it, because this isn't just an eclipse. This is a stack. An eclipse, a planetary parade, a meteor shower at peak output, a possible solar storm, and 4 active comets all clustering near Earth at the same moment. Individually, each of these is interesting. Together, I think something else is happening. And I want to walk you through all of it, point by point, so you can see the full picture and draw your own conclusions. Now let's start with the eclipse itself, because the mechanics matter. A solar eclipse happens when the moon sits between the Earth and the sun during a new moon. That alignment isn't rare. It happens every month. What's rare is the moon being close enough to the ecliptic plane and close enough to Earth in its orbit to actually block the sun completely. To more. Rho, the moon is near perigee, its closest approach to Earth, which means it appears just large enough in our sky to cover the sun's disk entirely. That's what gives us totality, rather than just a partial eclipse or an annular ring of fire eclipse. The path of totality arcs from the Arctic, cuts across Greenland, sweeps over the western fjords of Iceland, and then races across the Atlantic before ending at sunset over Spain, right around Mallorca. Everywhere else in Europe and parts of North America will see a partial eclipse. If you're in heat path, you'll get a window of 1 to 2 minutes of true darkness in the middle of the day. Stars will come out, temperatures will drop, animals will go quiet. It's disorienting even when you know it's coming. After that, an annular eclipse crosses the country as well. 3 eclipses, 1 country, back to back to back. If you believe these events carry any kind of energetic weight, Spain is sitting inside a very unusual window right now. Now let's talk about what's happening in the sky at the same time, because the eclipse isn't the only headline. Starting tomorrow morning and continuing for the next several days until Mercury pulls ahead in its orbit, you'll be able to look toward the eastern horizon before dawn and see 6 planets lined up across the sky. Jupiter, Mercury, Mars, Uranus, Saturn, and Neptune. Jupiter and Mercury will be tough to catch. They rise close to the sun, so you'll need a clear, unobstructed horizon, and you'll need to look before actual sunrise. Mars and Saturn will be much easier, visible even with some light pollution. Uranus and Neptune are the real challenge. You'll want binoculars or a small telescope, though under a truly dark sky, some people claim they can spot Uranus with the naked eye. One thing worth noting, these are 6 planets, and Venus, our brilliant evening star right now, isn't part of the lineup. She's on the opposite side of the sky entirely. Draw whatever meaning you want from that, but it's a detail that sticks with me. If you want to actually go out and try to catch this parade yourself, here's how I'd plan it. Give yourself a full hour before official sunrise, because Jupiter and Mercury are going to be sitting low, close to the horizon, and close to the glow of the coming dawn. You need a genuinely open eastern horizon for those two. No bill. Dings, no tree line, no hills. A coastline, a flat field, or high ground all work well. Mars and Saturn will be considerably easier. They'll sit higher in the sky, away from the brightening horizon glow, and you should be able to pick them out even from a suburban backyard with some ambient light pollution. Uranus and Neptune are a different challenge entirely. Neither one is going to reveal itself to the naked eye under anything but the darkest, most pristine conditions, and even then, it's a stretch. For Neptune, bring binoculars if you have them, or better yet, a small telescope, and use a stargazing app like Stellarium or a comparable sky mapping tool to get their exact position dialed in ahead of time. Because hunting for a dim blue-green dot without knowing precisely where to look wastes most of your viewing window. I'll also say this, don't treat the parade as a single morning event. It holds for several days running, right up until Mercury pulls ahead of the pack and slides toward its next conjunction with the sun. That gives you multiple chances if the first morning gets clouded out, and it gives you the chance to watch the alignment subtly shift from one morning to the next, which is its own kind of satisfying if you're paying attention. Now, I want to be clear about what this parade actually is, because there's a common misconception. These planets are not physically lined up in space like beads on a string. If you zoomed out and looked at the solar system from above, you would not see a straight line. What you're seeing is a relative alignment. From our vantage point on Earth, these 6 worlds happen to appear along roughly the same arc of sky at the same time. It's a perspective effect. That doesn't make it any less striking to actually go outside and see it, but it's worth understanding what you're looking at. 6 planet parades aren't unheard of, but they're also not something that happens every year. And whatever you make of the astronomical rarity, I'll say this from personal experience. During planetary parades, I notice my dreams shift. They get more vivid, more synchronistic. I've had lucid dreams and moments that felt like precognition during these windows. I can't prove that to you, and I'm not going to pretend I can. I'm telling you what I've observed, and I'd be curious whether any of you notice something similar over the next few nights. Next, the meteor shower, because this is where the eclipse and the sky show start to overlap in a very specific way. The Perseids are active right now. They run from mid-July through early September, and they peak tomorrow, August 12th, on the exact same day as the eclipse. That timing matters more than it might seem, because tomorrow is also a new moon, which means when the sun sets, moon sets with it. No moonlight washing out the sky. That gives us close to perfect dark sky conditions right when the Perseids are at maximum output. Current tracking from global meteor networks has activity levels above 100 per hour, more than one visible meteor every 60 seconds, with the possibility of a sudden burst pushing even higher. Here's the detail that gets me. The total eclipse itself creates a pocket of near total darkness in the middle of the day, right along its path, right as the Perseids are ramping toward peak. It's possible, not guaranteed, but possible, that observers in the path of totality catch a meteor or two during those 1 to 2 minutes of eclipse darkness. If that happens, the footage is going to be extraordinary. I'll be watching for it. If you want to catch the Perseids yourself over the coming nights, here's the practical advice. Go out after midnight. The later the better, since the shower's radiant point, the constellation Perseus, climbs higher as the night goes on and peaks near dawn. Just don't wait so long that the rising sun starts washing out the sky before you've had your window. Now let's talk about the sun itself, because there's a wild card here. On August 8th, the sun launched a coronal mass ejection, a burst of charged plasma flung out into space. The launch was dramatic. If you look at the ultraviolet imagery from that event, there's a plasma filament eruption that visually resembles the numeral 8, launching on the 8th, in a year that adds up a certain way if you start doing digit reduction on the date. I'll leave you to decide how much weight to put on that kind of numerology. I notice it, I mention it, I don't build my forecast on it alone. What matters more practically is whether that CME actually hits Earth and when. The forecasting on this has been messy. Initial models showed a solar storm impact landing sometime within 36 hours of that August 8th launch, a G1 class geomE. Magnetic storm, which is minor but real, capable of producing visible aurora at high latitudes and some fluctuation in the geomagnetic field. Then newer models came out showing essentially nothing happening. Then space weather monitors caught an actual interplanetary shock arrival, a small one, early in the morning, which forecasters believe was the leading edge of that same CME. Solar wind speed ticked up modestly from around 350 kilometers per second to around 436. The magnetic field strength spiked briefly and dropped back down. In other words, a whisper of an impact, not a shout. Whether that's the whole event or just the first ripple ahead of something stronger is genuinely unclear even to the people running the models. What I'd say is this: given everything else converging on the same 24 to 48 hour window, I'd lean toward expecting more volatility rather than less, even if the official forecast keeps getting revised down. We'll know more by watching the solar wind data directly over the coming day. Now, the comets. This is the part of the story most people are missing entirely, and I think it deserves far more attention than it's getting. Right now, 4 short-period comets are clustered near Earth, all within striking distance of their perihelion, their closest approach to the Sun, at nearly the same time. These are Jupiter family comets, meaning their orbits typically live in the region between Mars and Jupiter, swinging inward roughly every 5 to 6 years. The 4 in question are 10 Power Tempel, 169P Neat, 220P McNaught, and 88P Howell. Let's go through them one at a time because the numbers are worth sitting with. 220P McNaught reached perihelion back on June 14th. On June 3rd, just before that, it underwent a dramatic outburst, brightening by roughly 40,000 times its baseline. That's not a typo. An outburst like that happens when a comet, H, heated by increased solar radiation as it swings closer to the sun, releases a sudden burst of gas and dust from its nucleus, sometimes from a fresh crack or exposed pocket of volatile ice. We've watched this kind of event happen in close-up before, notably with the Rosetta mission's observations of Comet 67P. It had a second outburst, starting August 5th. By August 7th, its coma, the diffuse envelope of gas and dust surrounding the nucleus, had expanded to roughly 1.5 times the size of Jupiter. By August 11th, new imaging showed 2 distinct layers to that coma, a visible bow-shock-like structure and a coma that had grown to roughly the diameter of the Sun itself. I want to be precise about what that means, because it's easy to overstate. This is volume, not mass. The coma is an extremely low-density cloud of gas and dust, nothing like the density of a planet or a star. But it's not inert gas either. Also Zentidai. In the space environment, that gas and dust becomes weakly ionized by solar radiation and the solar wind, turning it into what's called a complex dusty plasma. a state of matter that behaves electromagnetically, not just gravitationally. So when I say McNaught's coma is now roughly the size of the sun, I mean there's a genuine plasma structure of that scale sitting in space, about 1.2 astronomical units from Earth, coincident with everything else happening this week. 10P Temple reached its own perihelion just days ago on August 2nd, and is currently the closest of the four to Earth, about 0.41 astronomical units out. Its coma measures roughly 467,000 kilometers across, on the order of half the sun's diameter. 169 neat is closer still, just 0.168 astronomical units from Earth right now, with a coma close to the size of Jupiter. 88P Howell sits farther out, around 1.73 astronomical units, with a coma measured at roughly 302,000 kilometers, nearly double Jupiter's diameter. 4 enormous plasma envelopes, all near perihelion, all clustered close to Earth's position along the ecliptic plane, all active at the same time this eclipse and meteor shower and possible solar storm are converging. If you track their positions over the past several months, you can watch Earth swing past this cluster in 2 distinct waves, an initial close pass in the spring, and now a second pass happening right now through September and into October, before the formation starts to disperse in November. I'm not asking you to accept a mechanism for why any of this matters. I'm laying out what is objectively, measurably happening in the sky above us this week, and letting you sit with the fact that it's a lot, all at once, all pointing at the same handful of days. Let's also put these comets in context, because 4 comets can sound abstract until you understand how unusual it is to have this many active, sizable comets clustered in the same stretch of sky at the same time. Most weeks, if you're tracking short-period comets at all, you're lucky to have one worth mentioning, a Phi. A T-smudge in a wide-field telescope, visible to specialists and dedicated amateur astronomers, invisible to almost everyone else. What we have right now is 4 separate nuclei, each one actively venting gas and dust, each one building. Now, a coma large enough to be measured against planetary bodies for scale, and each one making its closest pass to both the Sun and the Earth within weeks of one another. That's not a coincidence of any single comet's orbit. It's an alignment of several independent orbital periods happening to overlap in the same short window. If you chart out their positions across the year, as I did earlier, you can watch this cluster approach Earth in 2 distinct waves, months apart, which tells you this isn't a single flyby event. It's a sustained convergence that's been building since spring and is only now reaching its most intense phase. I'd also add that outbursts like the one we've seen from 220P McNaught aren't purely random. They tend to cluster around perihelion, when solar heating is at its maximum and the pressure on subsurface ice pockets is highest. But the timing, size, and duration of any individual outburst is still something astronomers can't fully predict in advance, which is part of why the imaging community has been watching this object so closely over the past several weeks. Every fresh image tells us something new about how the coma is evolving, and right now it's still growing, which means we genuinely don't know what it looks like by the time you're watching this. Now let's bring this back down to Earth, literally, because the ground has been busy too. Yesterday, a magnitude 7.4 earthquake struck Colombia. The death toll has already passed 300, with roughly 3,000 people still missing. This came just weeks after a 7.2, 7.5 double event struck Venezuela on June 24th, and a 7.3 struck near the Guatemala-Mexico border on July the 17th. That's 4 earthquakes at or above magnitude 7 in about 6 weeks. 7.2, 7.3, 7.4, 7.5. Landing back to back to back across the same general region of the Eastern Pacific and Caribbean plate boundaries. Volcanic activity has picked up alongside it. Fuego in Guatemala became more active following the Mexico quake. A mud volcano in Colombia activated after yesterday's event. Mount Etna, sitting almost directly under this eclipse's broader path of influence across the Mediterranean, has a C in increased activity. Hawaii's Kilauea has logged 52 historic eruptive episodes in a short window, with signs, based on ground tilt data showing the volcano's magma chamber inflating faster after each recent deflation cycle, that a 53rd episode could arrive within the next day or two. It's worth being honest about the base rate here. There are, on average, 40 to 50 volcanoes erupting somewhere on Earth at any given time. That number hasn't spiked. What has changed, if you're watching closely, is the intensity of eruptions at some of the larger, more closely monitored systems: Etna, Fuego, Shiveluch, Kilauea. And on the seismic side, we haven't seen a magnitude 8 earthquake since the devastating 8.8 that struck Kamchatka on July 29, 2025, one of the strongest quakes ever recorded, which triggered a prolonged burst of seismicity across the Western Pacific. That energy appears to have migrated. It's now showing up in the Eastern Pacific, Venezuela, Mexico, Colombia, and I think there's a reasonable case that the stress loading from this sequence nudges fault systems further north, toward Central America and potentially into California, and further south along the subduction zone into South America, closer to rupture. One more thing worth sitting with on the seismic side, the coverage gap. A magnitude 7.4 earthquake with a death toll already past 300 and thousands still missing should be leading every major news cycle on the planet right now. Instead, it's barely registering outside of specialist channels and local coverage in the region itself. I bring this up not to turn this into a media criticism segment, but because I think it matters for how you calibrate your own sense of how active this period actually is. If you're only getting your information from mainstream headline aggregators, you may not even know 4 magnitude 7+ earthquakes have struck in 6 weeks, let alone that they cluster geographically along the same general plate boundary system stretching from Mexico down through Central America into Venezuela and Colombia. That's the kind of pattern that's much easier to see if you're tracking the raw seismic data yourself rather than waiting for it to be packaged into a headline. So here's where I land on all of this. I'm not telling you that an eclipse causes an earthquake. I'm not telling you that a comet's plasma coma reaches out and cracks a fault line. I don't have a mechanism for that, and I'm not going to pretend I do. What I am telling you is this. We are living through an extraordinarily dense window of convergence. A total solar eclipse anchoring the day, a 6-planet parade in the pre-dawn sky, the Perseids at peak output under perfect dark sky conditions, a possible geomagnetic storm still working itself out in the data, and 4 massive cometary comas clustered near Earth at their closest approach. All L, ending inside the same 72-hour stretch, on top of 6 weeks of major seismic activity that already produced 4 earthquakes above magnitude 7. Whether you read that as coincidence, as amplification, as the whole being greater than the sum of its parts, or is nothing more than the ordinary background noise of an active planet that always has something going on somewhere. That's genuinely up to you, and I'd rather you sit with the row. Do your data yourself than just take my framing of it at face value. I lean toward thinking these things don't happen in a vacuum, that when this many systems light up together, the noise floor of the planet goes up with it. But I want to be honest that this is interpretation, not proof. The data on the eclipse, the planets, the meteors, the comets, and the earthquakes is real and verifiable. The story of what it all means together is the part I'm asking you to sit with, not the part I'm handing you as settled fact. If there's a shift coming out of this window, I don't think it announces itself on the 12th. These things tend to have a longer tail, effects that surface days or even weeks after the anchoring event. The Colombia earthquake hit 2 days before the eclipse, and I'd still put it inside the same window of volatility. So if something else moves, geologically, atmospherically, even just in how strange people's dreams get over the next week, I wouldn't be shocked if it traces back to this stretch of days rather than to the 12th specifically. There's one more piece I want to leave you with, because I think it matters more than most of what I've covered so far. How to actually watch this responsibly and what to look for over the coming days if you want to track whether this convergence is producing anything measurable. First, on the eclipse itself, if you're anywhere in the path of totality, or even in the partial eclipse zone, do not look directly at the sun without proper solar filters, except during the brief window of full totality itself, when the disk is completely covered. Certified eclipse glasses, a pinhole project, Hector, or a solar filter on a telescope or camera are the only safe ways to view the partial phases. This sounds like basic advice, but every major eclipse brings a wave of emergency room visits from people who didn't take it seriously, and I'd rather spend 10 seconds reminding you than have anyone in this audience deal with that. Second, on tracking the aftermath, if you want to follow along with me on whether this window produces further seismic or volcanic activity, the tools are publicly available. Global Seismic Monitoring Network posts real-time earthquake data, typically within minutes of an event. Volcanic activity can be tracked through tilt and inflation data from monitored systems like Kilauea, and through satellite thermal imaging for more remote volcanoes. Space weather agencies post updated solar wind speed, magnetic field strength, and geomaggy. Kinetic storm forecasts multiple times a day. None of this requires specialized access. It's the same data I'm pulling from when I put these updates together, and I'd encourage you to look at it yourself rather than just taking my read on it. Third, and this is more personal advice than scientific advice, however you interpret a window like this, as pure coincidence, as something with deeper resonance, or somewhere in between, I think it's worth treating these next several days as a moment to actually pay attention. Go outside, look up before dawn, watch the eclipse safely if you're in range, or follow along with a live stream if you're not. Ice your own dreams, your own sense of the world over the coming week. You don't need to accept any particular framework to get something out of that kind of attention. Most people never look up at all, and a stretch of sky like this one, An eclipse, a planetary parade, a meteor shower at peak, and a cluster of comets, all inside the same handful of days, is not something that comes around often enough to take for granted. Tomorrow, I'll be live as the eclipse happens, tracking it in real time along with the meteor activity and whatever the solar wind is doing by then. If you want to watch the sky actually go dark with me and see whether anything else lines up as it happens, that's where I'll be. The sun goes dark first. What comes after is what we're all about to find out together, and I intend to be watching every step of the way, right alongside every single one of you, from the very first minute to the last.